Hey there, everyone. One of the things I wanted to talk about is something that I surprisingly don't see much from in the community for Docker, and that is using a local client to connect to a remote swarm or remote host. A lot of people don't realize, but Docker is not just a daemon that is accessible from the local host. It is a client server architecture. When you issue Docker commands, those are actually running through a Docker client. Um, Both the client and the server will actually have different versions, but you can actually configure your system to, when you issue Docker commands on your local machine, like my laptop here, that they're actually issued against a remote host, and those are done via environment variables. So we'll do. You can see there are two here. The first one is Docker host, and that just indicates the protocol first being TCP, and the host and port to connect to the remote host on. The TLS verify basically indicates that both the client and the server both have to agree on the fact that this client will identify itself with a valid X509 certificate signed by the same CA the other system is using as its server cert. This is basically a way of authenticating based on certificates as opposed to passwords, and it's far more secure. It can be a pain to manage certificate revocation and management, etc., but this is a very secure mechanism for managing your connections. So if I issue a command, that's not actually happening on the local laptop. That's happening on swarm01.dockstar.net. One way I can prove that is on the network, Docker network ls. You'll notice there's an overlay network called demonstration. You'd have to actually have a swarm defined to have an overlay network, and demonstration is an overlay network that spans both host swarm01 and swarm02. So the amazing thing is, if you think about this now, I can make direct connections, spawn containers against the remote hosts without having to access them. The other thing is, you can actually lock down those hosts such that they can only receive connections this way. You can basically say, don't use the local Unix socket. So that means if you were to SSH onto that box and issue a Docker command there, it wouldn't connect. You would actually still have to connect to the public address and then use a certificate. That is the most secure I think you can get. But the big thing is, I want to walk this into how important this is for DevOps, because as an individual, as just an administrator, I can define services this way. And think about it with Chef. Chef has a server, but you have Knife locally you define stuff with, and you push cookbooks to the server. Let's go ahead and just create a service, and I'll show you where the power from this comes from. Docker service. Create, name, demonstration, network, demonstration, P. We're going to map 80 on the hosts to 80 on the container, and we'll just run, well, let's do replicas 2 and Nginx. So at this point you can see we have two services running. So the important thing about this is, and it's important to know for several reasons, if we access this server, you get the basic site for Nginx. If you access 2, you get the same thing. Now this is a good thing and a bad thing. It means we can scale our Docker hosts laterally. We could have 50 hosts in the service. All of those hosts would listen on port 80, which is the problem. A definition for a Docker service causes all hosts to listen on that port at all times. So if you use common ports like 80, while that service is running, you can never deploy anything else on it. Commonly, it's best practice to use abstract ports like 8096 or just something in the high range that'll get represented to a user later via load balancer. But so here we have this service. It's deployed. The great thing about this is, if you notice, I can see one of these containers running. And I'm just gonna be like, I don't think you need to be running. So it stops. You notice for a second we show one of two replicas. Over time, right there, the Docker Swarm Manager has realized the state of the cluster is not what it's supposed to be, so it spins up another container. This is the high availability aspect of Docker. But I want you to realize, as we get through this, think about this not from an administrator, but think of this from an automation standpoint. Now, let's say 2 is not enough. We need more containers. Let's say they just take longer to respond, so you want to scale laterally. We can do Docker service update demonstration replicas 32. And you'll notice the manager begins spinning up replicas to match system state, or the desired state. Now that's a little heftier than we need, so we'll just change that back down to 2. And you'll see the other side of this, where it slowly scales it back down. Or, what if we didn't want Nginx? What if we wanted Ubuntu? The power of what just happened might not be evident. We just took an entire defined service with X amount of replicas. Now this is just going to keep dying over and over, and I'll go to it in a second. We'll go ahead and destroy the service. But we just basically said, I know I've got 2 or 32 instances of this container running, and then we said, you know what, let's change the image it's running. Think about that more from version control. Let's say you write an application, you're on version 1.1, and then, but you need to update to 1.2. Well, in Docker, if you've already built your image, that's literally as easy as telling it Docker service update image and the new image, whether it's in a local repository or Docker Hub. And that's how I use Jenkins. In Docker, or in .NET Core, Jenkins, whenever there's a tag event in GitLab, it will trigger a build. The build will restore and build in an image context based on the name of that tag. So if it's 1.7, it will create a Docker image for 1.7. And that will get pushed to the registry. Jenkins, once that is pushed, will then connect to each of the hosts via this mechanism. Basically, it's just going to change the environment variable for the host and say, I'm going to force it to download a new image and then perform a service update. And at that point, the engine handles the deployment of the code. It's a very powerful and often overlooked mechanism, and I just wanted to get a little bit more visibility towards it. If you have any questions about how to configure this, basically the only thing you really need to look for is protecting the Docker socket. This information, or this tutorial here, will walk you through the complicated components of how to set up the CA certificate. When you have more than one host, the important thing to remember is to keep your CA certificate in your key. It will have to be transferred to the next host and used to generate the server certificates. That's just to make sure that they all have the same signing authority. That would also mean all client certificates valid for server 1 would be valid for server 2, etc. This may be a little overwhelming for most people because X509 or OpenSSL can be kind of cryptic, but if you have any questions about it, feel free to hit me up at Docstar on the website or daryl.breeden@docstar.net, and we'll be more than happy to help you get through this, because once you get past this part, you may not have to touch it for a year or longer. And actually, if you go by the default, the certificate creations are for a year, 365 days. You can actually set that to something like 10 years. It's really up to you. But this is one of those things you would do it and very unfrequently revisit it. Because what will happen is once that certificate expires, the Docker host won't be able to accept connections. Your client won't be able to connect to it because both sides of the handshake aren't valid. The client will see that the server certificate has expired and just blow up. It's like, no, I can't do that. It's not secure. So yeah, it's kind of a complicated subject, but there's a lot of power to it. Not only from the fact that you don't have to actually maintain credentials or keys to access the servers and you can manage them remotely, but more from a DevOps automation standpoint. So like I said, if you have any questions about this or would like to see examples, hit us up and we'll get you going.